Hey guys, it's primary and secondary tutorials here today, and I'm going to show you how to simplify a radical expression. So here we have the cubic root, or square root, of 64, x squared, y to the power of 3. So how we're going to go about this is first, we did pretend that 64 is to the power of 1, and we're going to pull all our exponents over 2. So it'll be 64 to the power of 1/2, x to the power of 2/2, and y to the power of 3/2. And anything to the power of 1/2 is just the same as getting the square root of it. And the square root of 64 is 8. Now, with this x, the question you ask yourself when you do this will be, how many times does your numerator or your denominator go into your numerator? And 2 goes into 2 once, so you just get x. Now here, 2 goes into 3 one time, but it also leaves a remainder of 1. So we get a y outside the radical and a y on the inside of the radical. Now, if it were y 5/2, it would be y squared with, again, y, just one y on the inside of the radical. So now we combine it. And here, we're going to simplify this radical expression, except now it's a cubic root. And so again, we have to pretend that our 125 is to the first power. So now it'll look like 125 to the third power, or to the power of 1/3, x to the power of 7/3, and y to the power of 2/3, with z to the power of 15/3. And so this is just finding the cubic root of 125, which is equal to 5. So how many times does 3 go into 7? Well, it goes in twice, leaving a remainder of 1. So that'll look like x squared with x under a radical. How many times does how many times does 3 go into 2? Well, it doesn't. So it'll just be y squared under a radical, because we have a remainder of 2. And I'm sure the z is easy. How many times does 3 go into 15? Well, it goes in 5 times, leaving no remainder. So it'll just be z to the power of 5. So combining it will look like 5 x squared z to the 5 power, then our radical sign with x, and then y squared under it. And don't forget to make it a cubic root, because it is a cube root at the start. And here we have a little bit of a different problem. We have to find the quartic root of 16, x to the 8th power, y to the 5th power, over x to the 4th power, y to the 5th power. And here we just need to know a basic exponent rule. X to the power of a over x to the power of b is equal to x to the power of a minus b. So we do realize that our y's have the same exponent. So this makes it really easy to get rid of them. It'll just be y to the power of 5 minus 5, which is just equal to 1. And so they cancel out. And we really could have canceled them out from the start, because they have the same base and they have the same exponent. And so pretending that 16 is to the power of 1, and you do 16 to the power of 1/4, that is just equal to the quartic root of 16, which is equal to 2. And now you put x to the power of 8 over 4. Well, 4 goes into 8 twice, you get x squared. And now you have x to the power of 4, put that over 4. 4 goes into 4 once, leaving a remainder of nothing. So we have x squared and x1. Again, we can use our exponent rule. X squared over x to the power of 1 is just x to the power of 2 minus 1. So we just get x. So here, our answer is just going to be 2x. Thank you very much.